Hey React Summit, I'm here to offer 7 lessons to outlive React. So the premise for this talk is that React is older than jQuery was when React was first released. And jQuery isn't dead. It's just, it's still powering a huge amount of the internet, but it's just no longer as cool as it once was. And that fate will come for React someday as well. And we should try to think about what will last beyond React. So as we look at React on its ascendancy and coming into its very mature phase, we should think about what lessons we learned from its enormous success. So hello, I'm Swyx. I work on a bunch of different things, and I do a lot in the React community, but mostly I give React talks, which is the most relevant qualification for this conference. And a lot of these talks are focusing on individual elements of React, but this is the first talk to really cover the overall philosophy, which I think can take away from that. If you want to dive into individual details, these talks are really good to cover the technical foundations from which I draw a lot of these principles. So the 7 lessons up front are presented here. We'll talk about the Reconciler, API surface area, API design, optimizing for change, testing, dev tools, and community. So the first part is that the Reconciler and scheduler pattern is probably a really good idea for a bunch of different jobs. And this actually comes from Jordan Walk, which is his original insight, that whatever it is your program produces, pixels, files, anything, just make your program regenerate the whole thing every time, add caching and structural sharing to make it fast, and that's it. And obviously, that's a lot of the original pitch, which I captured from the original JSConf talk. And that's the way that React sort of differentiated itself from the beginning. But maybe it's also overlooking the other MVP of React, which is scheduling, right? Which is the other part. And we're seeing a lot of innovation now when you switch over from old React to concurrent mode React, you start to get the benefits of time slicing, which is talked about a lot. If you want a further primer on scheduling in React, definitely check out Philip Spice's blog post, which I featured here. This scheduler is actually starting to see implications beyond React. So the React core team actually split out the scheduler package into its own package in the hopes that other frameworks might be able to use it. And they're working with the Chrome dev team, that should be from the Chrome dev team, to maybe build it into the browser. So if you want React built in the browser, this is the start. But overall, I think this actually encapsulates the idea of a DX UX mullet. That's my term for it, where you have immediate mode in the front and retained mode in the back. So immediate mode, like just re-render the whole thing every single time for both the front end, the user, as well as the developer, and retain mode, which is the system in the middle, which actually retains the state. And this is actually true for build systems. So Jared Palmer is actually working on a build system where he has the exact same pattern. And you start to see this pattern over and over again in GraphQL with ETL pipelines, Nullify, and a lot of other different aspects of life where you have a developer working with the system and you want to make it fast, but also easy to reason about. Okay, second lesson. Minimal API surface area. This one, of course, comes from the seminal talk by Sebastian Markboga, actually laying out this philosophy. And he basically, based on his experience working with Moo tools, says that a lot of library patterns are just too big. There's just too much API, and they're not going to last, and it's actually hard to undo once you've actually created that API. So his solution is to just never try it in the first place. And you prefer an explicit and repetitive API rather than an implicit one. The trade-off, of course, is that we'll have a lot more boilerplate, but you see a lot of these examples in how React grows over time. So React actually voluntarily removed its own proprietary class format for ES6 classes. You can actually see that React's design used, like for example with hooks, where you can see the third-party hooks, like the user-defined hooks, are on the same level with the first-party core hooks, and that's a concept that comes from Guy Steele's talk, Growing a Language, which I highly recommend. And also you can see that React tries to collapse APIs, right? They'll have these 3 very common component class APIs and collapse it into GDSFP, and then also they write a blog post to remind you that you may not need it, especially if you use functions. So just less and less API over time, and I really appreciate the React core team for that. But there is a cost, which is that you give up. There's no routing solution, no state management solution, no styling, and all that comes with React. And this is stuff that other frameworks take for granted, and that React developers struggle with. So there is a cost to that. We'll comment on that in a future lesson. But lesson number 3 is that API design is language design, and this is very similar to the previous point, but distinct. And the emphasis here is naming, and the way that people talk about React. So Lee Byron actually had a huge contribution to this even before he co-founded GraphQL, by sitting down and actually nailing the concepts, the actions, the operands, and the notifications. You can see the result of that in the design API choices of React. And these are the ones that we're familiar with. But they've changed a lot over time, but there's still a grammar that's been established that we can come to expect and recommend. And it makes sense to us as React developers. It helps us think in React based on the language. And that's part of this appear wharf hypothesis, which is that naming actually helps to shape our thinking, or the words that we use helps to shape our thinking. You can also see this in hooks, right? The way that use whatever is a very common naming syntax for hooks, or the recommended naming syntax for hooks. And just the name of hooks itself, like these are all the other 50 other names that were considered for hooks before they landed on hooks. And partially it's with a consideration that you want something that's one syllable so you can refer to it in daily conversation. That's also an API that humans use instead of computers. And overall, I think maybe Dan put it the best. He says UI before API. You want to start with the end result, and then you work backwards to create the APIs that help you get there. But his other principle is really interesting as well. He says hacks and then idioms, which means that he's willing to let users hack around whatever you have, rather than building in an extra API just to accommodate them. And here it's very clear what it is. If you're of a certain generation in React, where you have a lot of wrapper components just to inject something with Redux or like GraphQL, and this pyramid of doom, I love adding in a little Hadouken in there just to symbolize how deep it really goes. There are a lot of solutions that try to result in fixing this. Well, there's a lot of solutions that actually result in this, and you just don't have a choice because React didn't really give you another way. So if you wanted to inject data, or inject state, you needed a higher order component. There was a brief revolution for render props, again from the same people that were recommending higher order components. And then I was trying to resolve this big pyramid of doom thing. I actually introduced a React RFC called react.headless component. And all of these were just like ways in which to inject behavior, which were just like not really right, and we all realized that hooks were just a much better option towards the end. Lesson number 4 is to optimize for change. So this is the final point on API design, which is that you shouldn't optimize for don't repeat yourself, or you shouldn't optimize for minimal lines of code. Optimize for change, and here's why. So the first order of design is that your code should be easy to read and write. You should have all these characteristics. I really like the pit of success one is pretty commonly stated, that you want to make the right thing the easy thing. You want to be memorable, like Lee Byron making the grammar for React. That's very memorable. You want it to be guessable. That's a really good tip from John Otander. And you also want to encourage performance, accessibility, safety, and user experience, right? These are all equally important. Don't make any value judgments on which one's more important. But once you've written the thing, then requirements start to change, and that's where second order design comes in. You want to also make it easy to change. So if you have very brittle code, then a slight change in requirements will make your code fall apart. So the great API design actually anticipates that you want to rename or copy and paste, unify into abstraction, or break apart an abstraction, to delete or add a hack, do all sorts of things to your code, and it needs to just not fall apart when you try to do that. So a great API not only lets you fall into a pit of success, but helps you stay there, and that's a really, really good observation. And that's something that you see a lot in other formats. So 2 references I would like to point you to if you want to look more into this is the Stack Overflow blog, where they call this requirements volatility, as well as Hillel Wayne, who calls this requirement perturbations. Same idea, different takes. The React team's solution to solving this is to enable local reasoning, to try to reduce as much global context as you need, and just to focus on the code in front of you, and that should allow you to change whatever you need, because then you actually don't have to have spooky action at a distance. You see this in React's blog, in Dan's blog posts, in Sophie Alpert blogging about data loader. You can see this in style components, Tailwind, or the relay compiler design. There's a lot of different ways in which you can enable local reasoning. that helps to make things optimized for change. I have a lot more slides in this I had to cut out because I don't have time, but feel free to hit me up, because optimizing for change is a fundamentally really important idea that will last way, way longer than React does. Okay, lesson number 5, test the public API. Very, very simple one. You should write tests, not too many, mostly integration. Don't test implementation detail. This was obviously very, very important for React, because the React undertook a huge rewrite of the whole code base, but kept the tests. And the tests actually outlasted the code base. And that's not something that's very insightful for your apps. Obviously, they also implemented this little tracker thing for Is Fiber Ready Yet, where they actually tracked the completion towards the rewrite. And it's just a really motivating thing to see for the React code base. That's actually spread as a movement towards React apps, right? So we've seen Enzyme sort of relatively declining compared to the React testing library. And that's as it should be, because React testing library has this focus on testing only the public API of components. And that's what your users will use, and that's the only thing that you should really care about for your tests. And it makes it so much less brittle compared to what was there before. Okay, lesson number 6. We're moving along to dev tools. Dev tools are not optional, and you can see how much React emphasizes dev tools. So of course, the React official dev tools, the Chrome plugin, is maintained by Brian Vaughn on the React core team, and he does an amazing job. Like, I don't know how much I'd pay for this, but I would pay for this. And you should learn all the intricacies if you want to debug. React also uses code mods. This is not optional for React, basically because the React team actually has to maintain the tens of thousands of components that are in the Facebook code base, and they have to upgrade all of them whenever they change the APIs. So of course you have to automate these things, and we as the React community get to benefit. The React dev warnings is something that is really taken to the limit with React. So you can see the React error overlay, or you can see lint warnings, and you can see it in the console. We even have error codes, so you can see nice errors in production, but not have extra weight in the final build out artifacts. And that's a very nice decoder experience, which I wish that more developer tools copied. You can't automate everything, so it's nice to introduce some fixtures. I really like this as a way to learn React as well, because you can start to toggle on feature flags and change different browsers and see how the behavior changes. It's just a really nice way to manually test things by having everything in place, so you don't have any time setting it up. And finally, the last tip is kind of like a meta tip. Tools to hold dev tools to help you build dev tools. So for React, because it's building a library that's going to be embedded into millions of other applications, they need to keep the bundle size small and to never increase them without unintentionally. And it's something that we can actually borrow for our apps as well. We should be aware of what we're building and shipping, and should be aware of big regressions. So dev tools are not optional. The last lesson is that we should not neglect community. We want to build a community as well. This is obviously, it goes back to the beginning of open sourcing of React. So Jordan Walk actually had to introduce JSX because he was being ignored internally within Facebook. And once he introduced JSX, they really liked it a lot better. But then the exact opposite happened when they open sourced to the public. This is Jordan there in the headlights trying to introduce JSX and to a very bad reception. And here's Pete Hunt trying to rescue it by saying, "Hey, it's optional, guys. Like, don't worry so much." And I think we eventually came around to the idea. But the core of it is that the whole early core team really listened to feedback. They were on IRC, on Stack Overflow 24/7, and they replied to every single piece of criticism, viewing them as their fault. And that work in the community paid off. They started to bring over a lot of users, and in particular David Nolan from the ClojureScript community, who built Ohm and really started to hype up React quite a bit. And I think that's a lot of legwork that is maybe forgotten to time. But I think if we're starting to create our own projects that we want to be as popular as React, we need to start to pay attention to community just like they did. And that's a lesson that we take along with us. Also, we need to start solving pain points. So one of the big pain points was React is so small that it doesn't solve the rest of the other applications, and people started to make memes and jokes about it. So Dan Abramov actually went and create React app, and that's a story that I tell in a separate talk called Create React app. But in general, the story of this is basically that it's a distribution of React, right? You bundle React with other things, and Next.js and Gatsby bundle it with routing, and Blitz and Redwood bundle Next.js, and so on and so forth. You can bundle and bundle and bundle. And what we're really seeing here is a cooling down in the creative destruction of frameworks and a maturation and deployment of React. And we're starting to build on top of React rather than trying to compete with React. And the main thing that the contract for React starts to shift, right? Now the main thing that React ships is not features, it's stability. Of course, the S-curve is not at an end. It can start to S again when concurrent React is fully out. So the 7 lessons that we covered are all of these. I think it's going to be a bit hard to remember if you're 7. Working memory is only 3 to 5. So here's my breakdown. First, you have a core idea of whatever your library or framework is going to do. Then you want to work on the interface between the developer and your core library. So that's your API design. Then you want to productionize it, by working on the testing, by working on dev tools. And then finally, you want to humanize it to make sure to meet people where they are. And that's the 7 lessons. There's not the only 7 lessons that you can learn from React, and there's more on the way. The React team is very generous in sharing their lessons on concurrent React. And so you should pay attention to those. But overall, the meta lesson I want to leave you with is that you should fall in love with problems, because the solutions come and go, but the problems will always remain. That's it. If you want to learn more about these principles, which I think will last our entire careers, you should check out my book at learningpublic.org. But otherwise, thank you so much for having me, and see you in the rest of the talks. Bye.